So, so that's what the extend layer does. And like I said, I've only shown you a very small part of this CD. There's 8 other principles. And the ergonomics has an interesting one where we actually model a small car repair shop. And from an OSHA inspector's point of view, if you were to change things, which ones would you change first? From a manager's point of view, which one would you change first? From an employee point of view, which one would you change? So you got to click and drag and manipulate some things. I typically use this when I'm going out of town. Show them for about 5-10 minutes in the class, and then let them loose and give them a pretty long exercise at the end that tells them, well, they actually have to go through this what do you call this integrate layer, which is modeled after the Defense Logistics Agency warehouse that I mentioned, and tell me which principles were applied, which ones were not. Again, there's a lot of information there, but I also asked them to look at one of the 10 principles, and I give different principles for each student, and just write a detailed I guess summary of that principle, including the key aspects and where would you apply it and things like that. So that's CD, and I'll close that off and quickly go back to my PowerPoint file. So maybe I have about 10-15 minutes. Okay, which one, 10 or 15?
But before we go away, how can I ask a question?
Sure.
How you incorporate 10 principles, is CD into your course? Like it should be in the middle or the back, or just give us the assignment?
Well, obviously I use my own textbook, which has one chapter in facilities in material handling and one chapter on warehousing. So before I get to the material handling topic, I introduce the CD. But really you could use it at any point in time. And now I'm asking my department chairman, my colleague John Usher, who teaches a second year in a sophomore course, intro to IE type of thing. I actually, he might be using it in that, but that's a good place to use it also. So really anytime, I tend to use it around the time I travel, the Informs meetings and so on. Okay, so we went through all of this. I'm going to skip through that. This is the other CD that was produced as part of the same project, and a lot of the credit needs to go to Charlie Malmborg and Bob Graves, who were actually leading that effort. It was part of the same NSF grant, but they took the lead on this one. And this is actually an entire warehouse modeled after the Gap warehouse. I think I'm allowed to say that now. It used to be confidential many years ago. The Gap distribution center in New Jersey. I've never been to that plant, but I don't know where it is, somewhere on the eastern seaboard. Peekskill? Yeah, I thought it was New Jersey, but could be that, yeah. Okay. Again, I think it might be worthwhile to just go directly into the CD. And this is a slightly different format, or actually it's quite a bit different from what you saw in the 10 principles of materials handling, because this CD will allow you to actually get into the design aspect. So this particular warehouse has 5 areas. You've got inbound trucks that bring in clothing in a cardboard box, and there's a deunitizing station where somebody will actually take the shirts off of each carton, put it into a tote, send the tote to ASRS area, and then the cardboard, we put it on an overhead container, and it's taken out for recycling. And some of the questions that you have to deal with include how many operators to have, can you speed up the conveyor, and if you do that, what are the consequences on foot and things like that. A lot of the calculations are based on simple queuing models, but they're fairly accurate. They're not exact, but they're fairly accurate. I would not recommend that you open this with any other browser than Internet Explorer. My default is Google Chrome, and so I need to go back in. No, don't want to do that. Okay, so it's that file called index, and I'm going to open it with Internet Explorer. Okay, so it allows me a few minutes to promote my book once more. That's not the intent. But this is a warehouse that it's modeled after. So you have the ASRS area, where you store all the T-shirts in totes, the mini-load ASRS area. This is the deunitizing area. And I think it doesn't like my using the mouse with that. I mean the pointer. Okay, so this is the deunitizing area, the ASRS area, and then there's 3 others, and I'll go through that. There's a conveyor area here. You click on that enter, you'll be taken to a set of screens that describes warehouse. How much throughput they have. And again, you can click on these buttons to go from one slide to the next. Okay, so there's all this information here. So let me just read out a few. It's a national chain of teen fashion clothing retail stores. They need to build a distribution to go to the individual retail stores. And the multiple areas that you're going to be looking at would be deunitizing that I mentioned, ASRS, kitting, and this one is, maybe you can read it better there, palletizing, yeah. So once the orders are put together on a pallet, then you palletize them. And yeah, I can't read that last one. Pallet storage, okay, thank you. So let me go through maybe just the ASRS area. But each one of them is interesting because you've got a combination of, figuring out how many people to have, what speeds to have for the operating equipment. Do you use random storage or dedicated storage? Different choices you have to make. And before you actually end up, configuring or designing a system, you actually are presented with an overview of that particular area. Lots of animations here, so you can actually find out what an ASRS is like by clicking on that button. But the idea is once you understood the basics of, say, an high density storage area, then the idea is that you're going to start selecting the technology. You're going to configure the system, and then you're going to analyze. So first part, which is selecting, would be you got a set of choices to select from, random versus dedicated, how many ASRS, how many aisles are you going to have, how many tiers, and so on. Once you've done that, then you're going to configure the system so that if you made these tweaks, then the throughput is going to increase or cost is going to increase. So you end up with a subset of 2 or 3 solutions. And the analyze part is where you're presented with 4 demand scenarios. Back to school demand, Christmas demand, summer demand, and so on. And you can actually test your design through each one of those 4 scenarios. So I'll just show you again some of the animations here, and then a few things from this slide. Again, this also has a lot of content, and I would encourage you to go through this, every layer or every area, and kind of try it out once before you actually go to the class.
Section pertains to the automatic storage and retrieval system, ASRS, area of the distribution center. The 2 main tasks of the ASRS are to receive, fill totes from the deunitizing or kitting areas, and to retrieve totes based on demands to fulfill store orders.
Okay, so I'm going to skip directly. We can actually go to the other aspects of the overview layer, but I'm going to go to the select. And this is where I can actually select random versus dedicated. But before you do that, you can click on these hyperlink texts to see what random storage is and even see an animation of that. Notebox, again, this is a place where you can actually take notes. I'm going to skip all that and take you directly to this icon. So anytime you see this wrench here, that means you are able to play with that system. You're able to enter information. So in this case, all you can do is select random or dedicated, and you can actually do both, create multiple designs and see which, how each one stacks up against the other. But that's a very simple selection, right? Here you can also now select the number of aisles, the number of columns of storage, and the number of tiers. So use a slider if you like. Well, I guess you have to use a slider. Again, random versus dedicated. So what I have is I've selected configuration that requires 7260 spaces, but I'm allowed 20,400. So I guess I could increase the number of tiers. But remember that any selection you make obviously is going to improve the cost, but maybe it also maximizes my throughput. So that's that. Select the crane to be used. Again, you got a choice of, I think, 5 cranes that you can do of varying speeds, and you can look at different selections and see. I think this is the cost. Okay, the cost is in the vertical axis, and then the load transfer time is on the horizontal axis. Obviously, the faster the equipment, the lower the transfer time, but the cost also increases. So that's another selection that you can make. And so you keep on building on this design one step at a time, and I think this is where you can generate alternative designs. So not just the ones that I initially selected, I can, so the first design is saved as option 1. I can change things around, maybe different conveyor, different type of crane, maybe a dedicated storage policy. I can save that as option 2. Okay, so you can generate your own up to 5 designs. And then after you're done with it, let me go to the configure layer. You can look at the interleaving policy, whether you want to do single command, dual command, or opportunistic interleaving. And all of that is explained with text, but also voiceovers and animations. So how does the policy that you select, how does that impact, if I were to do dedicated, what happened to the transaction time? If I were to do random storage, well, what does that do to the number of transactions per hour? So lots of different things that you can change here. So that's the configuration layer. And then finally, when you go to the analyze section, you will be able to download multiple, 4 demand scenarios: back to school, holiday season, winter clothes, and summer clothes, and see how each one of your 5 designs stacks up against the different demand scenarios. So in this case, the particular design that I selected has the utilization rate of 567%, and obviously that's nowhere near feasible. And so that's just one of the 5 areas that I showed, and I know I'm taking too much time. It's Monday afternoon, and we got one more speaker and then bowling ahead. So I'm going to stop here and maybe hold off questions until the end again.
Yeah, you're going to be around for a while.
I'm leaving tomorrow.